a technology that sits on top of Kubernetes. So it is a Kubernetes add-on. Those of you who are familiar with Kubernetes know that there are, I don't know, a couple hundred Kubernetes add-ons, but Knative is the one that we're talking about today. So Knative is made up of different sub-projects. We have Knative Serving. Ooh, I'm shaking, friends. It looks like a kindergartner's writing it. Whoa. We have Eventing. And then I was at KNativeCon, and they're talking about starting a new project called Knative Functions. So that's coming soon. There's a working group for that. Whew. I'll calm down soon. So we're going to be focused today on Knative Serving. We're not talking about these other pieces of Knative. So when you say, oh, I know everything about Knative, just know you don't know. You just know about this part of Knative. All right. So Knative simplifies and enhances the way that your application runs on Kubernetes. So that's almost like a marketing speak when you take all this stuff and you just combine it into one sentence. That kind of makes some sense, but doesn't really say anything. So to really get, and like let's focus on this simplifying how your application runs on Kubernetes. And to really understand what's happening there, let's talk about how your application runs on Kubernetes if there's no tool in the picture, if it's just running on vanilla Kubernetes. So if you're an application developer and you have an application that you want to run on Kubernetes, first you put it into a container image. And then you make a Kubernetes deployment. Yes, I'm getting better. It's steadier, steadier. All right, so deployment. Now the deployment will manage a replica set, and that is something you define within your deployment object. So we have a replica set, and the replica set is concerned with keeping the right number of instances of your application running. And then the replica set will manage one or many pods. The pod is the smallest unit of compute in Kubernetes, and it is what is actually running your container image that you care about. The one thing you care about in this whole thing is this little teeny blue box. So that isn't terrible. Like, why do we need Knative in the picture to help make this better? Well, as it stands, as you may know, Kubernetes is a distributed system. So this may be happening, Kubernetes may be running it across 5 different computers. And you don't know where these pods are on those 5 computers. So for you to, first it's a mystery in itself to find the pod. Once you do find the pod, you can SSH onto the machine, access it with your IP address. That's cool, that's not very efficient. But then pods are also ephemeral. So in Kubernetes, if something starts to break, a pod just goes down completely and a brand new one is spun up. So then that IP address that you took so long to find just went away on you. So that's not, nobody does it that way, of course. And not even vanilla Kubernetes users do it that way. What happens is there's another Kubernetes object called a service. So a service's job is to keep track of all the pods related to the application that it's in charge of. And so it's supposed to, and it gives it like one unified way to access it. And so it knows where all of the pods are, and then it also knows, it also will load balance between them for you. So as someone who's deploying their application, I have to know a little bit about all of these abstractions, and I still can't access my application from outside of the cluster. Now I can access it more easily once I'm in my cluster, but it doesn't accept external traffic, and so we make an object called an ingress. So we make an ingress. An ingress knows where all of the services are in their cluster. There's probably going to be a lot of them. This shaky handwriting is hilarious. So it knows where all the services are, and it also knows, so it'll keep track of like which domain name is going to lead to which service. It's where you configure your TLS also. And then if you want to take full advantage of your Kubernetes cluster, you probably are concerned with a horizontal pod autoscaler. And you also probably need configuration for your application. So that's going to be in an object called a config map. And then probably some of that configuration should be secret. So we're going to manage that with a secret object. So there you go. That's all you need to worry about to deploy it to Kubernetes. Easy peasy, right? So that's where we're talking about this cognitive load that developers have. Developers, you should be developing your application. That's all you should be worried about, especially when this is redundant and the same for every single project that is ever going to come across the whole system. So what does Knative do to help solve this problem of developers needing to know all of this Kubernetes stuff? So to use Knative, this comes as a shock. You'll need to install it. So first do that. Or really your operator is going to install it probably for you. And then you also, I have here, what I have is a Google Cloud cluster. I have Knative installed into that cluster, and I have the KN CLI on my machine, among some other things that I'll talk about later. So with that set up, I can run this command. So with the KN is for the Knative CLI. Knative service create. I'm going to give my service a name. We're going to call it Sunshine. And I will supply it with my container image, which is going to be rainbows, actually. So with that, when I run that command, what's going to happen is a Knative service is going to get spun up. Now I take the time to say and write Knative service. I'm a relatively new learner, and when I was first getting my hands dirty with Knative, I spent a really long time trying to figure out what a Knative service has to do with the Kubernetes service, because they're both called a service. Nothing. They have nothing. They're like totally unrelated things. So don't waste your time with that. So here we are. We made a Knative service, and then what that Knative service is going to return to us, what that command is going to return to us in the terminal is a URL where we can access our running application. And that's it. It's that easy. So all those abstractions that we talked about, they're all being managed under the hood by Knative, and you get your URL. But friends, you don't have to take my word for it. Let's do this thing. Okay, we never need to look at that again. So I have this like little cheat sheet that's purposely fully too small for you to see, and I didn't even. So that's just so you don't have to watch me type. If I can't draw because I'm shaking so badly, could you imagine if I was typing? Okay, so here we are. We have Knative's service creates. We're calling our service Sunshine, and we're giving it a rainbows image, which is just a V1. So it's our first version. See, that's just me trying to type one character. All right. So we're going to do that. Here we are. Live demos are horrifying. All right, here we are, ready to serve. And so here we have this URL, and we're going to put it here. Bam! There's our rainbows image that's running in the cloud. Now, some of you, I'm looking around at you. Please don't be clever and try to run this on your phones yet. Later, I'll tell you when to do it. If you do it now, you're going to wreck some stuff. Thank you. Please and thank you. So let's see so that was all done imperatively. Best practice is to do it declaratively with YAML. It enables you to do infrastructure as code. It enables you to do GitOps. So what, actually so this is the YAML that would do the exact same thing as what my Knative CLI command did. So it's about 10 lines of YAML. There's probably at least 110 lines of Kubernetes YAML that you would need to mess with the objects directly. And then finally, I'll briefly show you the Sunshine service, but we'll talk more about it later. So it made this object called a Sunshine service. Yay. And so something magical that can happen, but won't happen today because of Let's Encrypt rate limits, is that this URL that's returned also in 2 seconds after it returns to you a insecure URL, that the Let's Encrypt, you can configure auto TLS with Knative, and it'll give you a secure URL. And it's actually pretty easy to do. It's not happening now because of Let's Encrypt rate limits. Too many 50 certificates for SSL IP.io have already been issued this week, so we don't get to see the magic happen right now. But that's a cool thing that happens. So let's get back to drawing. Thank you for your patience while the screen mirroring happens. All right. So I don't know about y'all, but if you tell me a cool fact, like Knative simplifies the way your applications get deployed onto Kubernetes, I will remember that fact for 10 minutes. I might even remember it until I leave the room. But as soon as I'm out of this room, I'm thinking about lunch, I'm thinking about what sessions are this evening, I'm thinking about the after party, and I've pretty much forgotten it. So the thing that helps information sink deeply for me is if I understand how it works. So this isn't mirroring, is it? I think I got excited to talk and then turned off the mirror immediately, didn't I? Here we are. So what I'm going to do is talk about all the stuff that's happening under the hood to enable what this really cool trick. It's not a trick, kind of undermines it. So anyway, we have our Knative service has created some objects. The first object it's created is a root. Now the Knative root object, it concerns itself with the networky things. So like the service and the ingress from our Kubernetes cluster. And then it also is going to spin up a configuration, a Knative configuration. The configuration object is concerned with our pod specification stuff. So that might be a port number, that might be an environment variable, maybe what image you're using, or if you're using persistent storage, maybe a persistent volume claim, that sort of thing. The configuration will manage a stream of immutable revisions. So far, we've created revision 1. And there are going to be a few. So the configuration is going to manage a whole stream of revisions, and a revision is a snapshot in time of your current code and your current configuration all smooshed into one object that cannot be changed. So if you do anything to change your revision, if you do drastic changes where you have new backing services, a whole new image, all this stuff, you spin up a new revision. If you sneeze on your application and change one environment variable character from lowercase to uppercase, it's also going to spin up a whole new revision. And then our revision is going to manage the Kubernetes objects that we talked about before. So we have our Kubernetes deployment. We have our replica set. These are still all getting created, just not by you. We have one or many pods happening. Excellent. And then finally, a little blue box that we love, our running application. So what happens is we go to our root. The root by default is going to send 100% of traffic to the latest revision unless we tell it to do something other than that. And then the revision will say, hey, yeah, I got a pod, and send the traffic through to the pod, more or less. So that's what's happening to enable that. So let's get back to the terminal here. And we're going to look at all the resources so we can see that all of these objects got created. So here we are. We have those Kubernetes services. We have a Kubernetes deployment, a Kubernetes replica set, and now we're into our Knative stuff. So we have that Knative service, the Knative roots, the Knative configuration, and so far just one Knative revision. And you can also see our revision number right now is 00001, so all the Kubernetes objects related to this particular revision are tagged as such, so you know who they belong to. There's one thing I drew in the diagram that's not showing up here, and you know what it is? The ingress I don't see here, and I don't really know about that, so let's not talk about it. What I want to point out is a pod. There's no pod here. So this is when I knew about, so when I first learned that Knative existed, when I first heard those syllables come out of someone's mouth, I was on a pre-sales team, and someone else on my team working on another client project was dealing with Knative. So I heard it during stand-up. I looked it up, and I'm like, Knative is serverless. That's the S word. I don't like it. It's Knative serverless. I put it, it's like, okay, I tried to figure out what serverless is. It's loaded and confusing term, but I put it in that box and filed it away. Knative is serverless. Knative, first of all, the word serverless I don't like, and what I prefer to call it is scale to zero, meaning when we leave it alone for a while, like we just did, it's going to spin our pods down so there's no instance of our application running. So unlike vanilla Kubernetes where there's always pods running, Knative is going to take those away if they're not running. I forget why I said first of all and then whatever. But so now we're going to demonstrate what we're going to do a watch command on our pods. We're going to refresh our application, and we're going to see some pods come up to serve that application. So let's do that. So we're doing a watch command on get pods. No resources found. And now we're going to press reload and jump on over. Bam! Woo! What a thrill, you guys. All right, so let's jump on over and see how that works. If I could change anything about the format of this presentation, would be to jump into drawing. The mirroring always takes a moment. If only it could move as fast as scale to zero, am I right? Okay, so to understand how this works, we're going to talk about a few more Knative objects. And before I do that, you know what I want is to start keeping track of a list of benefits. I like to keep a gratitude journal. This is my gratitude journal about all the cool stuff about Knative. So we can deploy it much more easily. So I'm just going to call that less YAML. We also have auto TLS, which you totally just have to take my word on. But since everything else, well, better knock on wood, but since everything else has been working, maybe you also have built up enough trust that you can believe me on this one. And then we've shown you scale to zero. So next I want to talk about a component that helps make scale to zero work, which is the Knative pod autoscaler. So I'm going to write autoscaler here, and then it's abbreviated KPA, Knative pod autoscaler. Now, what's cool about the Knative autoscaler as opposed to the Kubernetes horizontal pod autoscaler is the Knative pod autoscaler scales based on concurrency. So depending on your application, the number of requests your application gets might be a much easier metric to work with. But if you are attached to the horizontal pod autoscaler, which scales based on memory and compute, you can use the horizontal pod autoscaler. You don't have to use the one that scales based on concurrency. But scaling on concurrency enables a function as a service use case where you have a very small application that's meant to only serve one user at a time. So that's my very limited knowledge of the new Knative projects, Knative functions, that whole function as a service thing, that's where that's coming into play. So we have our autoscaler, and then we also have an activator. Now, the Kubernetes resources are attached to a revision, but the autoscaler and activator, those are cluster scoped resources. I actually do know about that ingress object. We can talk later. So the activator is what enables the scale to zero. And so it knows about all of the inactive revisions. Once a revision has no traffic going to it and the pod scale to zero, the activator is now in charge of keeping track of that revision. So when we sent traffic to our application and there was nothing there, well, whatever. What happened was the activator saw that traffic came into this revision. And it's like, oh no, there's no pods. So it's like, okay, give the traffic to me, give the request to me, I'm gonna buffer it, I'm gonna hold on to it, make sure it's safe. And then autoscaler, we need your help. We need to spin up some pods. And autoscaler is, hey, yo, we need to spin up some pods. And then a pod gets spun up, And through various mechanisms that I'm not going to get into here, they know the pod's ready, and that information gets passed back to the activator. So activator knows the pod's ready and then can send the traffic through to the running application, and nothing gets lost. So that's what happens there. So now what I want to do is now I'm going to bring y'all on board, and we're going to do this together. So I'm going to get this QR code out for y'all to be able to access our running application on your phones or whatever. Oops, I said the wrong thing. That's all I needed to do. Here we are, QR code. Here you go. This should get you some rainbows on your phone. And while you're doing that, I'm going to tell a story. We're all friends here. We're all buddies, yeah? If we're not, let's be buddies, right? So we have a company together, and we are just dominating our industry. We are on top. And our company, what we do is we serve static images of rainbows. We are the best at it. And just like any company that's doing the best, you need to stay on top. You need to work hard. We put together Gartner reports. We have the think tank of all the industry leaders, making sure we know the next big trend in the rainbows industry. And what that trend, we've done a lot of research, what that trend seems like it is spiders, which is completely shocking because I think a spider is the literal opposite of a rainbow. I can't think of a single characteristic those two things have in common. So we're ready to, the data clearly shows this is the next trend, so we're ready to put it to the test. So what we've done is we've come up with an application that serves static image of spiders, and we want to test it now. So what we're going to do is we're going to do tag-based routing. All right, so this is the commands. So we have Knative service. We're going to update our service. Our service is called Sunshine, and now we're giving it a new version of the application, which is spiders. And then so this new revision we know is revision 2. So that's Sunshine, the 0002 is revision 2, and we're giving it a tagged spiders. And then we're also saying we're pinning all of the traffic, 100% of traffic, we still want to go to revision 1. So when I run this command, we'll see that a new revision comes up, but on your phones, when you hit that new application, you're still just going to see the rainbows. So there's a spiders application running, but you could only access it if you know the secret, which don't worry, I'll tell you the secret. So here we are, we have our rainbows application, and it's still just rainbows. But if you want to see the spiders, at the beginning of the URL, put spiders with plural and then a dash. Spiders dash sunshine, it should say at the beginning. And there's our spiders application. So this is called tag-based routing. It's pretty cool. So we've done all the testing. We're very excited about how it's going, and it's testing well, and we think we might be ready to roll this out. But then we got a request from, we're really good at our company at making sure everyone feels heard, and so one of our junior developers was like, hey, I have an idea. Why does it have to be spiders or rainbows? Why are those, they're not mutually exclusive. Why can't it be both? And we're like, yes, that's it. That's the wave of the future, the spider rainbows application serving. So we're going to we made a spider rainbows application, and now we're going to deploy it, and we're ready for real life traffic to see it. But what we're going to do is we are responsible. We're going to send only 10% of the traffic through to the new application and still keep 90% to where it's meant to go and test the real traffic. So we have Knative service, that update command again. Our service is called Sunshine. Now we have version 3 of our application, which is spiders and rainbows. And we're saying traffic, we want 90% to go to revision 1 to our rainbows, and we want 10% to go to revision 3, which is rainbows and spiders together. So I'm going to run this command. I'm not going to spam the application until one comes up. You're welcome to do that. My son uses the word spam. That just means press the button a lot of times. Anyway, instead of spamming it, I'm going to describe the service. So we can see here that 10% is going to Sunshine 003. You can see that our spiders tagged revision 2 is still here. And then 90% is going to our original Sunshine application. So that's cool. So now we're going to send 100% of traffic through. It tested well, so we're going to send 100% of traffic through to our latest revision. There it is. And we can just do the same describe Sunshine command to see that 100% of traffic is now going through. So we did it. The world is so excited. Here's something I'm excited to show you too. The world is so excited. We did it. We're remaining the industry leaders. I'm gonna take it some time to draw out what's happening. I feel like I'm getting too far ahead in the terminal. So thanks for your patience while I mirror it down here. Let's talk about everything that happened in our diagram. All right, so to recap, we made a revision 2 that's tagged. And that's, we gave it a tag spiders. And then at that point, when new traffic came into the cluster, if it's just regular traffic, it went through to revision 1. But if it was tagged with spiders, then it goes through to revision 2. And then we decided we wanted to make a new revision that's spiders and rainbows. And that's revision 3. And so each of these revisions that we make have their own set of Kubernetes resources. So those are getting spun up for each revision. And I can show you that later. So then we sent 100% of traffic through to revision 3. Actually, we started at 90 to revision 1, and then 10 to revision 3, and now we're at a point where 100% of it's at revision 3. So let's write in our gratitude journal. What we saw some tag-based routing, and we saw traffic splitting. So our spiders are there, they're smiling. They don't have teeth. And what the problem right now is, we're being celebrated for being leaders, for just like thought leaders and just like this radical new idea. But there's a danger with spiders. One of the maintainers, like, they're witches, and unfortunately they're like lived up to the stereotype, and they put a vulnerability in our application. So we are serving this application that may or may not mine Bitcoin for the witches. so we need to roll back to the latest safe revision ASAP. And as you can maybe infer from what we've already done, to roll back to the last safe version is actually very easy to do. So we are going to update our Sunshine, and we're giving that traffic flag that we know, and we're just saying we want 100% of traffic to go to revision 1. So it's that easy to get all of our traffic back to revision 1 and away from the bad witches 1. So that gives us time to fix our vulnerability. So while they're working on fixing a vulnerability, I want to do a quick command to show you all of the resources that are now running as we spin up all these revisions. So we see a couple pods running. Someone must have hit the spiders application recently, because we still have pods running for that. We have our Kubernetes stuff. You can see the deployment's a nice example to look at. There's a deployment associated with revisions 1, 2, and 3. There's replica sets associated with revisions 1, 2, and 3. And then we still have only one each of all those Knative resources that we talked about at the beginning. So everything is as we drew it. So now we have our application is fixed, and we're ready to deploy our new application. So this one has, just to stick it to the witches, now our spiders are grinning extra big with teeth. When I was drawing this one, I thought, do spiders have teeth? And I'm like, I'm pretty sure they don't, but like, there's enough like vampire kind of imagery in my head that I thought, well, maybe. And so I look up, like, do spiders have teeth? No, they don't. And also they have a mouth that's like a straw. And so they do their digestion on the outside. So they like wrap up the fly or whatever and use their straw mouth to put the digestive juices, I'm sorry, you guys, I just into the fly, and then they like slurp it up like a smoothie. So, so that's how that goes. But that's what I learned. I was fascinated. So here we are. We have the latest revision is safe. We have smiling spiders with teeth. And there's no witches. The witches won't get mad at us. Oh, I still have my spiders tag up top. I'm the one keeping the spiders app alive now. There it is. Yay. It's so happy. So that is rollbacks. And the last thing I want to show you is a more experimental thing called duration-based rollout. So I think I'm gonna draw it before we do it. Am I? I need to learn some jokes. Where can you find a dog with no legs? Right where you left it. Maybe I won't. Oh, well, you know what has worked in the past is if I just. There it is. All right, thank you for your patience. So what we did was we made a revision 4, which is spiders and rainbows with teeth and no vulnerabilities. And right now we currently have 100% of traffic going there. We rolled back to revision 1. We rolled it back out to revision 4. It's been an exciting hour together. So we're going to put rollbacks up here in our gratitude journal. And here we are. So now this is an experimental feature, and it's called duration-based rollout. So what we can do here is we can specify, we can say we want you to, orange, I haven't done orange yet. We want traffic to go from revision 4, we're gonna drip it from revision 4 to revision 5 in a specified amount of time. And in our case, since we're short on time, we're going to do it over 60 seconds. But as you can imagine, in a real scenario, you might want to do it over several hours so you can be measuring your traffic. So let's try this duration-based rollout. I'm going to go ahead and write it in the gratitude journal because I'm here. Excellent. So let's do it. So with the duration-based rollout, first I'm going to describe our service with a watch command. So we're doing this because you can see which traffic is pointed at which revision, and this is going to give us more information than the terminal output, which is just measuring time for us. It's not helpful at all. So here we are. Here's our command. Let's make it big. Oops, wrong button. Excellent. So we have Knative service update sunshine, our image. We're at version 5 of the image now. We're going to annotate. We trigger the duration-based rollout with annotations. And the rollout duration we're saying is 60 seconds. So here we go. You can spam it on your phone to see it going. And so I'm going to show you. This is so it says the gradual rollout is in progress, and now it's just showing us time. I think this is the silliest output ever. Like, thank you, some time is passing. I didn't know. So we're gonna jump over to our watch command, and we can see, look, 16% of traffic is going to our latest and 78% to our, so that latest tag, so I mentioned at the beginning that 100% of traffic goes through to the latest revision. Once I started pinning the traffic in different places, it's gonna stay pinned to where I pinned it. And then if I want 100% of traffic to go through to latest again, or any amount of traffic, I need to specify as much. So the duration-based rollout goes from latest to latest, and it has to be the most recent too. I want it, so it's not super fully featured, but we can see that we have 73% of traffic there, so we're getting all of our traffic through to the newest revision. So I'm starting to wrap up. I'm going to tell you about installing. I'm going to tell you about how you can play with it. I'll maybe tell you about me. Maybe you're ready to hear it. Actually, I tricked you. Look, you have to learn about it. It's on your phones now. If you click it, it goes through to. So anyway, but let's get back to our drawing. I'm going faster now than I do when I practice, which I imagine is a thing, the adrenaline. Let's do a quick little trip through memory lane. Our benefits are we can deploy with less YAML. It's much easier to deploy on Kubernetes. And for me, that's like a really big thing. Yes,
So you mentioned as less YAML, right? Let's say we have configs, secrets, ingress. So to add those details, would they be as part of separate YAML again?
So that's so the idea is it all gets configured within Knative the one time, and then as an application developer, the experience is much easier. So it still does need to be configured somewhere. Does that answer your question? Yes, everything is Kubernetes YAML. You would use observability or any other Kubernetes tool in the ecosystem the same with Knative as you would with your Kubernetes. Great question. So you have less YAML. We have auto TLS. We have it can scale to 0. Don't say the S word. It does concurrency, so it can be a much better way to scale your application depending on your use case. With concurrency, you can set your concurrency to 1, so you can do functions as a service where your application's only meant to get one request at once. We have tag-based routing. We have traffic splitting. We can roll back, and we have duration-based rollouts. So let's jump into how to install. If you're installing it on like a real cluster, as opposed to just doing it locally so you can play with it, what you're going to do is you install the Knative serving YAMLs, and then you also next you'll need to worry about a networking layer. I'm a relatively new learner, and I just within the month learned that a networking layer is the same thing as an ingress implementation. These two things mean the same. So at the beginning, we have a service using the same name for two different things. In this case, we have two different names that both mean the same thing. And I think that's part of what makes the barrier of entry into this field so difficult sometimes is just the vocabulary. Okay, so we need a networking layer. So if you came in this room already feeling like you know Knative, you might have thought Knative has a bad reputation from back in their youth of being a heavy technology. And so that came for two reasons. One is this Knative, this serving and eventing, these binaries used to be all in one. And if you wanted to use either part, you had to install both. So that's fixed now. They're separate, so you only install whatever you need. And the other reason it had a bad reputation is because when you add a networking layer, that networking layer used to have to be Istio, which is a relatively heavy service mesh. It's just not even relatively, just heavy service mesh. And if you're already using Istio, or if you have a lot of use for the other functionality, that's great. It also works with Knative. But if you only need a networking layer for Knative, the bare minimum of what you need is Courier. So that's the lightest one. Although I will tell you, this is just anecdotal. When I was making this demo, I was having trouble with tag-based routing. And when I replaced Courier with Contour, then my tag-based routing worked. So that's all I have to say. It's anecdotal, but it's the bare minimum, maybe slightly less than the bare minimum you need for all of the Knative functionality. So you have these three different networking choices, and I understand that in the Kubernetes space, they're trying to standardize ingress implementations, and if Kubernetes is keeping Knative is keeping an eye on that so that they can work with that standardization spec once it's all fleshed out. So you install a networking layer, and then you would also configure your DNS, and then finally you can add that auto TLS. So those are the things you do to get Knative set up in a large cluster situation. But what if you just want to play with it and see all this stuff for yourself? Then you go to knative.dev, and there's a tutorial tab. So the tutorial tab will have you download that KNCLI, and then the KNCLI has a quick start plugin, and it'll walk you through all of this and give you all the commands. It has a quick start plugin, and that quick start plugin will deploy Kind onto your machine. So Kind is a Kubernetes cluster. Kind stands for Kubernetes in Docker. So Kind. It puts a Kind cluster on, installs Knative into it, and then you can immediately start playing with Knative. It's magical how simple it is. And with that, I think that's all I have to write at you. I can tell you about myself a little bit now, or do you have questions? Or both? Okay, no question. Yes.
Have you ever thought about getting Spideras to do some, toothy spider?
I didn't even know. I don't know what Spidera is, but yeah. Do their spiders have teeth? Yeah. Yeah. Oh, my son's 23. He's a software engineer, actually. Yeah. But I have a bunch of stickers up here, so please take some stickers. Oh, hey. Hello. What can I?
Yeah, so with Knative, or at least for this talk, what protocols? Obviously, you're really using web protocols, but what protocols does it support? Can it do just vanilla TCP?
Yeah, HTTP, I believe, is the big one. I don't know, honestly, and it might depend on what Ingress implementation you choose. So the short answer is I don't know, and I'm sorry. Yeah. That's something they're working on now. So where the tag doesn't have to be in the URL right now, and I don't. I was at KNativeCon 6 months ago. Who knows what they've gotten done in 6 months? So it could. The answer is maybe, but it's on their radar for sure. Yeah. Yes. You can configure that how you want your revisions to go away. But yes, they can definitely go away. And they should after some amount of time. Yeah. Yes.
So fluidification time and like actually running the function. It seems like it was pretty quick for you, but how's the cold start time on Knative?
How's the cold start time on Knative is the question. That's like the problem of getting that cold start down is just like the thing everyone loves to talk about, which is great. It's an interesting problem. So the cold start time in Knative can have a lot to do with stuff that you have control over in your cluster. So you can do things like pre-cache your image on every node to improve that cold start time. So in my then there are other technologies you can bring in, like Dragonfly uses peer-to-peer networking and then a different container image type so that it can work with bigger images faster with the Nidus image. So to answer your question, I think they're doing pretty well. I forget the metric right now for what it typically is. If you're dealing with bigger images, there are some ways you can work with to solve that, and that's something the Knative community is excited to talk about. And I recommend you go on the Knative Slack and the CNCF workspace and ask them their ideas about what strategies they should use for your particular use case. Yeah? Excellent. Thank you so much for coming. I'm Whitney. I wrote my first line of code in January 2019, and I've been a learning fool since then. I have a couple of streaming shows. One is called Enlightening. I have a light board that you may have noticed when you walked in the room. I host a show where people come on the light board show and they teach me something, and I learn from them, and I write it on the board as I understand. So I'm forced to prove that I really do understand what they're talking about instead of just saying It's a fun show. It's a live stream, and it's so kind and lots of engagement from chat and lots of questions. And then I host a second show called You Choose that I co-host with Victor Farsick on his DI DevOps YouTube channel. And that one we've created a choose your own adventure through the CNCF landscape. So we kindly pit different CNCF technologies that do related things together into the same episode. And then we'll have those, someone come on to represent each technology, say to build a container image, and then for a specific goal. And then each one gets 5 minutes to present. We host some questions, and then there's a vote for everybody that gets put out to the public. And whichever technology wins is going to gets built into our ongoing demo. So it's a new show. I have stickers for it. We've done only like 9 episodes. We've gotten our application from a developer's laptop through to a development environment where it could be developed and made lots of fun decisions along the way. And what else? I'm a KubeCon keynote speaker. I'm a CNCF ambassador. I do some things. I have fun. And I'm so glad to get to know you. And thank you so, so much for coming today. Please don't be shy. Say hi to me later. Thank you.